Okay, Open Source Antibiotics Mur Ligase meeting on Tuesday, the 13th of September. And I've got an issue up. I think everyone's seen it, and we can look at that in a minute, but I just want to make sure we have a chance to get through everything. And the first thing I think it would be great to hear about, if you are happy to talk through your slide deck, Adrian.
Yeah, certainly.
That would be of primary interest to everyone, I think.
Okay, right. Well, without further ado.
Are you able to share? Is that all right?
Yeah, can you see that or not? I don't know.
I have to give it a sec.
Just bear with me. I said without further ado. So,
if there's a technical challenge, I can share a program.
hang on a second. So, I might actually have to ask you to do that if you wouldn't mind.
No problem. No problem. Hang on a second.
Okay, right. So,
how's that?
Lovely. Thank you very much indeed. So, everyone, we're going to talk about the work we've been doing at Warwick over the summer. Essentially, we've had some problems to solve, which we'll talk about expanding the throughput of the assays that we do. And we'll talk about how we've actually capitalized on that for the screening of the atomized library for Mur Ligase inhibitors against Mur C, Mur D, Mur E from both coli and Pseudomonas aeruginosa. So, next slide.
Yeah.
Right, so essentially the rate limiting step in the work we've done has been the manual interpretation of data on things like Excel. So if you've got continuous data which we generate, the amount of data and the processing we require to generate an initial rate, which is the quantitative estimate of enzyme activity, is quite onerous. And in actual fact, if we're talking about the analysis of 20 compounds, and we consider that we're doing roughly quadruplicates and quadruplicate controls for each, it has been taking a ridiculous amount of time, up to 1 to 2 days, to analyze the data set. So what we've done, we've had in the lab a postgrad called Hector Newman, who now has a job at Bicycle, and Hector knows his way around MATLAB. And so what he's done, he's devised a program whereby, and so if you look on the right-hand side of the screen on the rate traces, what it does, it takes the first 5 points and it calculates by linear regression a slope, and it calculates a correlation coefficient. And then it extends its width of analysis to points 1 to 6, then 1 to 7, then 1 to 8, and so on, all the way to the end of the progress curve. And it's looking for linear regions, and what it does, it basically identifies the region with the highest correlation coefficient. In other words, the most linear region. And then we take that as the initial rate, and that has saved us a significant amount of time. Now we can do the same analysis in 1 to 2 hours. So we get our lives back to a certain extent. Right, next slide, please. So what we've done, we've tried to verify that what we do by longhand equates to what MATLAB tells us. And on the y-axis, we have percentage inhibition calculated from data generated by MATLAB for compounds 23 to 45 of the atom-wise library, and analysis of the same data longhand. And we get quite a decent agreement between the two. So perfect agreement would be a line of 45 degrees going to the origin. and a slope of 1, and we are quite happy with that. We're quite happy that MATLAB is cup half full, as accurate as we are, cup half empty, as delusional as we are. But basically, it's telling us what we think we've seen by standard analysis. So with that in hand, oh, sorry, next slide, please. So what you're looking at are a series of histograms which represent the screening of the entire atomized library against Mur-C. We have bars in blue, which are the actual activity, the inhibition we're detecting against Pseudomonas Mur-C. And bear in mind that the assays we do are coupled assays. What we've also done is we've also assayed the coupling system to look at the impact of the atomized compounds on the coupling system. And in some cases, they are significant. So a good result, for example, would be a very, very high blue bar with a much, much lower red bar associated with it, which would imply that the coupling enzymes aren't particularly affected. So because we were seeing an impact of the atomized compounds on the coupling system, we had a look at that in more detail. Next slide, please. Now, essentially, when we do these assays, we have so much coupling enzyme in there that there is no rate limitation of the enzyme you actually want to assay. That means these enzymes are present in vast excess to what's actually required. So we've actually tightened back the amount of coupling enzyme in these assays to see what we can get away with. In other words, what degree of inhibition the assay will tolerate. And quite easily, if we see coupling enzyme inhibition of the order of 50 to 60%, essentially, there's no significant impact on the rate of Mur Ligase, Mur-C activity. So with that in hand, we also consider the possibility that the atomized compounds themselves might actually be quenching fluorescence because we're running a fluorescence assay. So we actually trialed the atomized compounds against their impact upon the fluorescence of the terminal step in our cascade, which generates the fluorophore resirufin. And I can tell you that there is no quenching really in any of the compounds that atomize have supplied. So that is to say, the fluorescence we're measuring is a representation of what's actually happening to the enzyme activity in the well. So we've, on the right-hand side of the top, I've taken one part of the data I showed in the previous slide, just as an example. The asterisk is below the compound labels on the x-axis are those hits whereby we're seeing a level of inhibition of the coupling system that is so insignificant in those hits which give us greater than 70% inhibition that we can essentially ignore it. And I've listed those atomized compounds that have that property with respect to Mur-C in the So we have a collection of atomized compounds that appear to be genuine Mur-C inhibitors. And because we're really interested in multi-targeting, what we've done with these is then we've trialed these against E. coli Mur-D. Next slide. Now, for completeness, I've given the conditions we're using in the bottom left-hand corner, substrate and Mur ligase concentrations. The ATP concentration is designed so that if we're getting competitive inhibition with respect to the ATP binding site, then the assay will be slightly biased, towards it. The top left panel, which again is just a histogram of percentage inhibition versus compound, those compounds that are active against Mur-C, this is their activity against Mur-D. We've also completed this exercise for Pseudomonas aeruginosa Mur-E and E. coli Mur-E. So on the right-hand side are a compendium of data which basically shows those compounds that show greater than 70% inhibition at 1 millimolar. And of the 16 Mur-C compounds we've got, 9 are singly targeted just to Mur-C, 2 are doubly targeted, 3 triply so, and 2 quadruply targeted. That is to say, against all of the Mur ligases that we've tried. So what we've then done is we've established the IC50 values. In fact, we are going to be doing the whole table, but for the moment, we've concentrated on AW17, which targets the 4 ligases, and 49, similarly quadruply targeting, and compound 53. Next slide. So the top panel of 4 graphs are basically dose response curves, percentage inhibition versus compound concentration. The pink traces are the impact of AW17 against, from left to right, C, D, E, and E. These purple traces are the impact of AW49 against the same battery of enzymes, and similarly AW53. So what essentially we're seeing is some compounds, particularly AW17, are particularly potent against, for example, Pseudomonas Mur-C and Mur-E. Other compounds less so. What we are also seeing is a degree of sigmoidicity in some of these traces, which is suggestive of perhaps more than one mode of interaction. The one thing I would probably want to say at this point is that these are fragments and they're being used at high concentration in the initial screens. And we don't yet know exactly what their mode of action is. Certainly from an enzymatic perspective, AW17 looks particularly attractive, although folks might have a rather different opinion about its chemical tractability. I don't know. But that is where we are at the moment. The other thing I'd say is we have seen significant impacts of these compounds on the coupling system. Again, we are working at high concentration. We are working with fragments. I would imagine that, and it is a bit of a warning shot across the bows, because these compounds are inhibiting things like xanthine oxidase and HRP and so on. The specificity that we're going to require will presumably be engineered in on subsequent rounds of synthesis, or at least I presume that's going to be the case. And that's where we are at the moment.
Fantastic. Really interesting data. I've got questions. Does anyone else have anything they would like to ask immediately? I'll jump in. First thing would be, so obviously we have some structures of these guys, right? There were structures obtained by Laura of several of these compounds already. Are any of these the structures that were obtained? Is there any crossover there?
I would have to check. Laura?
Let me have a look, because yeah, I've been away these days. Let me have a look.
No, I just wondered if we get a clue as to what they're doing, right, from the structures we already have.
I mean,
that would be very neat.
Yeah, I mean, we'll be following up certainly with some mode of action work, looking at what these things compete against and so on. Because I gather some of these compounds actually supposedly act allosterically. In actual fact, if they do act allosterically, one of the phenomena you often see with allosteric interactions is sigmoidicity.
Just on that, were there any solubility issues with any of the compounds being used at high concentrations like this?
No. Okay. No. I think we got off quite lightly there. Likewise, we got off quite lightly with the issue about fluorescence quenching.
What are the coupling enzymes, just for interest?
So what we do, we basically take the phosphate generated by the ligase. That's consumed by purine nucleoside phosphorylase, which cleaves inosine to generate xanthine, well, hyperxanthine. Then xanthine oxidase catalyzes the oxidation of hyperxanthine through to xanthine, then to uric acid. And each oxidation step generates a molecule of hydrogen peroxide. And then HRP, hydrogen horseradish peroxidase, consumes that and converts Amplex red to the fluorophore resirufin. It also works as a spec assay, but the fluorescence advantage, of course, is the much lower volumes you can go to. All of the work we do at the moment is in a 10 microliter format.
And so how do you do the experiment that shows that there's no inhibition of that system? What's the beginning of it?
Essentially, if we're looking at the system itself, we give the same concentration of inorganic phosphate as we have substrate in there, so about 20 odd micromolar. We dilute down the coupling enzymes so we can measure initial rates, because usually they're present in vast excess.
Right.
And then we measure the rates of conversion of generation of fluorescence from phosphate.
Okay.
So there is no structures for these ones. And also they didn't show a specific binding on the SPR.
For the multi-targeting ones, I guess. I wonder.
Yeah, for the three.
Yeah.
The last.
I wonder
three.
if any. I mean, it would be interesting if any of these Mur C inhibitors that were found are ones we have structures for. That would be a very nice tie-in. So I guess we can check offline.
Number
right?
No, sorry.
None of these. I guess that would be good to know.
Yeah. We also have dual inhibitor. Well, we have dual inhibitors for C and E, which we've not done IC50s on yet. For example, AW5, AW9.
No,
and
none of them.
So, and also AW77.
Right.
Yeah, we don't have a structure for those.
Yeah.
So, wow.
Yeah. So in short order, as far as the atomized library is concerned, we'll complete it with Pseudomonas murf.
Right.
And then what we'll do, we're going to be doubling back, because although we've really pushed the envelope in trying to get these continuous assays to fly in a timely fashion, it's still the case that if we were able to do these assays discontinuously, there will be a significant saving in terms of time and material. So that is something we're still keen to solve, and we'll be doing. And when we can do that, then screening entire libraries as opposed to select versions based upon one complete screen is going to be a little easier.
Okay, great. I noticed also, I've got control of the slide so I can go back. Here's compound W, so that's the thing that Yuhang sent, right?
Yeah, that's right.
So that's behaving as expected, right? Potent inhibition of the C and no inhibition of the coupling enzymes?
Exactly so.
Okay. Great.
By the way, the positive control, since we're at it, that we use for D&E is ADBCP, and similarly, we can, the assays are clean in that respect.
Right, good, great. Okay, beautiful.
Thank you.
Well, we will gather together these structures in one sheet to see if anything jumps out at us, and we'll double check versus SPR and crystal structure data, Laura. I guess we just want to be double sure that we've got no overlaps here.
Yeah.
Because if we don't, that's quite interesting, isn't it?
I mean, one obvious thing to say is that these are hits that have been obtained in the presence of all the substrates of the enzyme. And I think that's going to probably be quite a significant consideration if you're looking at data obtained just with the ligand and the protein.
Yeah, from what I can see, there is not much overlap. Only compound 10, I think, for SPR data.
Okay, we should.
Yeah, compound 10, and I couldn't really measure any KD.
For the, just while we're talking about the SPR as a comparator here, are the data for that finished and done in the sense that we can finalize that? We've got the crystal structures, we've got the SPR data, and now we have this. Is that right, or is there more to do on the SPR?
Well, there will be more to do because there's not much overlap.
No, I mean just evaluating all the compounds, right? So the screen's been done. I had this memory, maybe I'm wrong. There was some
the
data
screen was done. Yeah.
Okay. Did you have the results of the compounds any compounds that showed binding?
Yeah, I have.
Is that all shared? Sorry, I think I must have missed it if it was shared.
Yeah, it should be shared with an Excel file, but I'll double check again where it is and share the link.
Okay, great. Okay, so but as far as you're concerned, Laura, that experiment's done.
Yeah.
Okay, right. Because I mean, ultimately, I want to collect all this together and then send this back to Atomwise to see if they're interested in trying to digest this as well. You know, in terms
I think I sent already to Atomwise the SPR data.
Okay, because I think they'll probably be interested in this, right?
Yeah.
Do you want me to liaise directly with them?
So I'm so sorry.
Sorry, do you want me to liaise directly with them, or do you want to do that?
No, we can gather all the data together in one go, because I mean, when we had the conversation a while back, when we started to get crystal structure data, they said, can you just fill in this form? And I've linked it on the issue for this meeting today, and I've given a little screenshot. Essentially, they want to know which compounds gave hits by which method, and to submit that back to them in the format that they want to see. And it's always introduces a bit of a roadblock when people ask for data back in prescribed formats. But ultimately, if we can fill that in, which I think we can now, we can send that back to them and they can do some magic on that and see if anything pops out. I guess the reason why it's quite interesting is because there are a number of hits against Mur there, and there were, of course, a number of crystal structures. And I don't know how many compounds gave us sort of what you might term a hit on the SPR, Laura. Was it a handful, or was it a decent number like we're seeing on the screen?
Depends how you look at it. It's a handful.
Okay.
So we got a lot of non-specific binders. I am sending you and Adrian the results that we shared with Atomwise on the SPR.
Great.
And the link to the crystal structures as well is on the same email. Great.
All right. Thanks. Because I'm assuming that if we have a decent number of hits out of the 90 odd or 100 odd compounds that were sent, if we have a decent number like this, then I don't know, subsequent analysis by Atomwise might yield something. If it's just a few compounds, it's difficult to generate something, I think. So it could be good. And I think we're ready to do that now, which is great. All right, well, it's very exciting. So you said you were following up with Mur F.
Yes.
Yeah. And is there anything else that is obviously next in the pipeline that you might want to mention?
In terms of what we're doing next?
Yeah, for these atomized compounds.
Well, the next logical things to do would be to actually start from an enzymologist's point of view, is to look at the mode of action. So in other words, to look at the impact of ATP concentrations under the substrates, right, which will give us an idea with respect to what binding sites, if any, they're actually targeting. And if we know that, if we're really lucky, we might even get order binding out of this. Maybe we can go back to the SPR and maybe set things up where we have the appropriate substrate. There, it turns out that one of these compounds, or more than one, requires the present element of the substrate to bind.
Okay.
So there'll be things, it'd be that type of thing. Yeah. But yeah, we're quite happy with it. We're quite excited by it. Thank you for the library.
Yeah, that's good. It's great. It's really great to see the data. All right. Any other questions on this, or questions for Adrian, or suggestions? All right. Wonderful. Thanks very much for sending that over. All right. I guess I was gonna, Laura, did you want to take the floor now in case you've got more data to show on the enamine library or the fragment screening and those things? You've been away, right?
Can you repeat? Sorry.
Did you have anything you wanted to share on screening of
other compounds? I don't have more updates. No.
Okay. All right. No worries.
I will be spreading on SPR once I get the competition compounds.
Yeah, all right, so let's switch to that. So I guess, so Yuhang and Ed, were you able to just update us on compound shipment? Ed, did you have something you could share on the status of the competition compounds?
I guess if you opened up the the summary issue.
Yeah, right, hang on. Wait. I think I've got the right one. Hang on. Yeah, hang on a minute. I will share this.
Okay. Yeah. So in the top left box, that very top left compound, we've kind of left it because that heterocycle has been a pain to make. So we're kind of shelving that one. The one to the right of that I've finished, so that's ready to go in the shipment. The bottom three are Daniel's ones. I guess you can just quickly say where he's up to.
Oh yeah. So the first one, I'm still working the synthesis. I just need to change one chemical and make it short steps. I was doing some bromination that was not working. And then I bought like another chemical. I'm just waiting to arrive. The second one, I have the compound with the double bond. I'm still need to do the diol synthesis to have the diol compound, the final one. And the last one, I also bought new chemicals because I was doing some reaction that was not working. So I actually bought the bromine imidazole and some boronic acid to do Suzuki coupling and then do the next steps. I'm still working the synthesis of those two.
Okay.
Yeah, so all the blue ones are already with Laura. The last pink one in the UCL comp sci is finished, so that's ready. And then that middle one in the TCS is also finished. Sorry, the next box between the two greens. Yeah, that one is also finished and ready. The Van Dan one, I did the reaction for the reductive amination and it worked, but I haven't been able to isolate it, so I might need to repeat that. But I think in any case, we would want to just ship whatever we have and get them tested while we continue working on the rest, just so we can get some data back sooner.
I think so, yeah. Yeah, so that would be an extra shipment of what, 5 or so compounds to Laura, something like that?
Yeah, plus you hang this one.
Yeah, sure. Yeah, for the competition. But then the blue ones are already with Laura, so that would be the set of the first sort of major set of competition compounds.
Yeah. Okay,
so we're going to send those essentially now, right? We're not going to wait.
Yeah. So there were 2 compounds left over from Cato. I've just done one purification today, and there's just one more left. But then that should be it. Okay.
Great.
I have one question, but I don't know whether it's really relevant. Are any of the precursors of the syntheses you're doing, are they also of any value to look at enzymatically?
The precursors, yeah, other things on the way. I don't know.
Yeah.
These are pretty small. I mean, we'd be talking about things that are, half a fragment kind of thing.
Okay.
So, I mean, I would guess not, but that would just be a gut feeling. Yeah, this guy, this 5-member ring with 2 nitrogens, a real pain. Really interesting. That looks like a fantastic little heterocycle. You could put in all manner of things. And
it doesn't look stable.
Yeah, because it's a aminal, right?
Aminal, yeah, but it's also got a acyl group on one side as well, which must make it less stable.
Well, just handling that, I think. So getting the diamine from the supplier
Yeah.
It's in a strange form with lots of water in it.
Yeah.
And then handling it, it's just been, bad. So I think in terms of feedback to you, Jan, this guy, even though it may look nice, is a dark cloud over the,
Oh, great.
over the synthesis.
Got it.
Okay, great. So that shipment will be going ASAP because things are ready. And then Yuhang, did you want to? I think you've already put some stuff up. I can just load it up because this will go in the same shipment, right? Yeah. Did you want to just give a background?
So these ones, so these 4 compounds are prepared, ready to go. There are. So I actually prepared to prepare a little bit more, just in case it needs to be used in the future, like against other mutagens. So that's for the Warwick shipment, and for the compounds to Seattle, I prepared more than 10 milligrams each. Still, in case they want to be more, use more. And they're supposed to be shipped by today, so Bart sent me the email, and which is really helpful. Yeah, that's
Right.
the updated ship.
So these added to Ed's samples will be going to Warwick, and
yes,
these going to Bart.
Yeah.
Got it. What just so remind me also, because I thought that in this case we're also sending the amine compound.
No, the amine compound still not purified. So we also the amount was not enough. Like the yield was not good. So
but we just need like a couple of milligrams, right?
Yeah.
Okay.
Just need to
Tiny amount. All right. Okay. All right. Okay, that's fine. So that's the shipment stuff. Any questions or additions to that, Bart? Yeah, I guess you wanted to know what we want these things examined with, right? So what's the target protein?
Yeah, I was just hoping to have to just assume that maybe I haven't really been paying that good of attention since Jan's been doing such a great job, and be very clear about what you hope to get co-crystallized with that.
Yeah, so feel free to chip in anybody here, right? But these compounds, so Yuhang, these are AZ5595, one of these, is that right? I forget.
Yeah, the 25-1P is the AZ595. Yeah.
Right, AZ595. So this is the enantiomer, which
has
lower. So this guy is the one that already has the published crystal structure with Mercy. Sorry, I've temporarily blanked.
6X9N.
6X9. From which organism?
Pseudomonas Mercy.
Right. So isn't the idea that we would like to try and have this crystallized with the other Mercies?
With the original Mercy as well as a positive control, do we need to? If not, then we can just test on other usages.
All right. If anyone's got any immediate suggestions for which protein this goes for, then please say now. Otherwise, it will dig up the what this compound has already been crystallized with, and we'll suggest changes. I mean, I'm pretty sure that this compound was one that had low levels of activity against Mur D and Mur. Am I right? So there was very little inhibition by the compound AZ5595. Is that right?
That's correct.
Right. So there's no point in doing crystallography with that, right? I think the point here is to try and get the same.
Well, not with Mur D, but I guess maybe Acinetobacter. I mean, I'm not sure what the point is for these compounds, and also the urea compounds haven't been tested against any place in terms of SPR or anything like that. So I think it's a real shot in the dark. But
yeah,
you can try them. Maybe that's something. I don't know if you guys are doing the nano DSF. How easy that's to do? Maybe would be the experiment to do, Bart.
Well, unfortunately, that's a lost capability since we don't have one at our site. It was at the UCB site.
Oh, okay. All right. So anyway, I mean, you can always put them in. It's just those are as far as I know, there's been no profiling of those top 2 compounds. So
correct.
I'm not sure where. I guess you have. It depends on which protein you have. you know, more sample of. You don't know how much Mur C. You know, I know sometimes your supply of protein can be limited. So, you know, how you judiciously use it, I guess, would be a question.
Okay, Joe. So what do you want to use crystallize with?
Well, the only thing there might be, you know, you've gotten a structure in Acinetobacter. I can't remember now which one. You had a structure with Acinetobacter for one of the AZ compounds, right?
Yep. Yeah,
So
we'll dig it up.
it's a little unclear to me, you know, what the value is of doing crystallography on this compounds at this point, unless you had some insight on, you know, another Mur ligase. You know, right now we know these don't bind to Mur D. We have that data, right? So I'm not sure what else, you know, it's been profiled, whether it's, you know, E and F. There's been any profiling against E and F for any of these compounds at Warwick or not?
No, not yet. But that is something I was thinking that we could probably do.
Yeah, maybe we need essays before deciding what crystals to do.
Okay,
That's what I
New,
would,
right? We don't have anything on these compounds, right?
No.
Yeah, I mean, I think I would strongly encourage before burning up some of, you know, our goodwill with Seattle, that we get some profiling of these, either SPR or biochemically, before, you know, spending time trying to get crystal structures.
Yeah.
Yeah, we're very willing to do it.
okay.
Oh, do I still need to ship the bottom two compounds? Or
No,
like,
I would hold off. I would hold off until we've got some profiling done at Warwick.
oh, okay. Then we can ship these 4 compounds to the Warwick first. Then
Yes.
after we get all the data, then okay.
Sure. So compile them with the competition compounds and send them all together.
Yeah. Okay. Right.
Great. Okay. And then Yuhang, did you want to talk us through this overlay you've posted, just because people won't remember what the idea was?
Sure. Sorry, guys. I try to make it compact, so it's a bit small. Might not be.
That's all right. If people can see that. So do you want to just walk us through what you've done here?
Okay, so I just did an overlay of the 3 protein structures, among which the ADOF is the new. Yes, the ADOF is the new crystal structure of the compound I shipped, the AZ compounds 4. I shipped last year against in the Pseudomonas ATP Mercy ATP site, and just to compare overlay these 3 structures to see if the compound AZ compound 4 is actually behaving in a similar mode as the AZ595 and the other compound AZ8074. So with these layups, with these overlays, we can see their modes of binding are pretty similar. Especially the 3 main key hydrogen bondings with the asparagine and tyrosine and with the pyrazole parts of the molecules. So these 3 interactions are very important, and they're all behaving the same. The other part is the pipette stacking. I'm not sure whether this is quite important, but it kind of helps the molecule sit in that position. And even though the AZ595 compound is behaves a bit different from the other 2, using the benzene ring to stack with the histidine. The other 2 still use the pyrazole part to bind with the histidine. So it's a bit different, but mostly is fine. And what adds up to it is I did the RMSD calculation. So individually, right, lie and in primal, and lie align the ADOF against 6x9n gets a value of 0.27, and 8 DOF against 6s9f, like it gives the value of 0.29, so which is quite good. Just in case we had a bit of bias generated during the process, I align the compounds individually as well. The AZ compound 4 against AZ 595 gives the value of 3.2 around ish, and the AZ compounds 4 against AZ compound 8074 gives the value of around 2.6. So they're decent, I think. From my point of view, I think it's decent, to see, okay, the binding mode are pretty much similar.
Okay. Thanks, Yuhang. The data's there on the issue if people would like to interrogate that more. Leads us because Jan's joined us. Thanks for coming along, Jan. That's very good of you. Let me just reshare that. I guess I was wondering if you had any follow-up to the things we were talking about last time on structures. So we were talking about these structures last time. And the issue was that we had the new Pseudomonas Mur structure, and I guess we wanted to confirm that that structure has gone for peer review. And there was a further structure with another AZ compound I think you mentioned last time. I just wondered if you remembered a month ago now, whether this had been taken on.
Yeah, so let me just quickly share the screen.
Oh, great, yeah.
Right now I'm prohibited.
Wait a minute. It's no good. Oh, there you go.
There we go. So there it is. That's the structure for that remaining compound. It was deposited yesterday under PDB code EGL or 8EGN, and the previous structure was just deposited yesterday under 8EGM. So these are 2 of the 3 AZ compounds that have been sent to us. Well, this one I should say the density here for the right part as it's displayed here is quite good. I could see, or it looks like the density for this bicycle here is a bit wobbly or is a bit thin. So it seems like there are few interactions that this ring, bicyclic ring, is doing. You switch over to the other chain, it gets a little weaker as well. So it seems that this part of the molecule isn't doing a ton of productive interactions.
Yep.
So my plan is to, after depositing, so it has been sent to the PDB yesterday. There still needs to be a little bit back and forth. They need to approve the structure. I need to approve it. They need to look over it. So as soon as that process has been done, I will publish it. There was a discussion a while back as to how to cite or which authors should be connected to this deposition. And if you guys could give me some clarity on who should be, apart from the standard list of authors that we have within SSGCID, I'm very happy to follow that. There were some folks at AstraZeneca maybe that might have to be included, but
yeah, that's right.
You guys
yeah,
need to give me guidance on that.
Okay, if you were able just to put very quick bullet point notes in an email and send that over, then we can consult with people about exactly what's what, and then we can link the structures and the small molecules that are involved there onto the issue, just for everyone to take a look.
I'll do that. Yep.
Fantastic.
And the
Thank you.
third AZ compound that is still pending. I have crystals. They're a little bit small yet, but I'm quite optimistic that I can collect data in a week or two. I can still do that in-house. I don't have the option to collect at a synchrotron, but I can do that in my 20% spare time. And I can, if we get good data, I can refine a structure on my commute and provide it to you with some delay, but it might still happen.
Not on your bicycle, surely you can't do that.
On the ferry, though.
Okay, fine.
No, I'm not.
Too much. Okay, that is wonderful. Thanks. Yeah, really good.
Yeah. Okay, I can stop sharing.
All right.
So
yeah.
Jan, if you need synchrotron time, let us know and we'll send it. You can pick up a doer or something and send it out.
Yeah. Okay, sounds good. Thank you.
All right. Those were all the main points. I think that were on the agenda and the issue. Is there anything big that I haven't gone over or had a chance to? People having a chance to speak. I think that will probably take care of the most important things as far as I remember. I'm just having a quick look, but I think that we've covered the latest data and so on. Yeah, that's everything. So I think unless anyone's got anything urgent or A or B, we can end at 10:02. All good?
Sorry, just one more question about the general procedures. The general procedures we are using, like for example, what Yang has been doing and what Laura has been doing. Like, is there like a general procedure we can refer to? Because I'm currently doing writing for the upgrade and thesis. Is there any help?
Yeah. So Yuhang, for his thesis, which is going to go in a month or so, will just needs to either refer to an existing publication where procedures for biological assays or crystallography have been described, or may need help with just some words to go into the supporting information, making it clear that the work's been done by somebody else, but giving a little bit of detail so that his examiners are able to understand what was done. So if he so, and eventually of course we'll need it for a full paper, but for the purposes of a thesis, for Yuhang's thesis, you may need just a few lines or a suitable reference to cite.
Okay.
If people could give those, if Yuhang gets in touch, that would be great.
Thanks.
Sure, just reach out, Yuhang. And
yeah, thank you. Thank you so much.
Yeah.
All right, great. Thanks so much. The next meeting will be in about a month's time. I can't remember when it is, but it'll be sometime in October. And I'm just going to look at it, and it's October the 11th, Tuesday, October the 11th at 2. And so I'll put an issue up and get the agenda going, and then we can work together online. All right. Thank you so much for your time, everybody. Great to see you all. See you next time.
Bye.
Bye-bye.
Bye.
Thank you, everyone.
Bye, Phil.